Alright, today we're covering Ohm's Law. You got to have a pencil and a paper out today. Make sure you pause the video if I'm going too quickly for you, or if you have to write notes, so that way I don't change on to the next thing too quickly for you, and resume when you're done writing the note. So go ahead, write down the title, Ohm's Law. These are the topics we're covering in this presentation. First and foremost, don't have to write any of this down, but this Georg Ohm, or maybe it was George, I'm not sure, he lived from 1789 till 1854, and he was a German physicist and school teacher. He's the guy responsible for what's called Ohm's Law. And so basically, he just discovered that there's a mathematical relationship between current, voltage, and resistance. So basically, he figured out that if you know two of the three, you can calculate the third. Kind of cool. So, like I said, if you know two of the three quantities, you can solve for the third. This table that you see in front of you right now is super duper important, but let me explain a few things. What we got here is our quantities, or our three parts of electricity that we had learned. So we got voltage, current, and resistance. If you want to abbreviate voltage, okay, so basically make it shorter so you don't have to write out the whole word, we abbreviate it as V. You can forget about this E. We're never going to use it. We always use V. Current, they abbreviate to I. Who knows why, okay? It should be C in my mind, but we use I. And resistance is R. If you measured voltage, what unit would you put in? So let's say you measured a battery and you got 9 volts. The unit is volt, okay? So it's 9 volts. If you measured current in a circuit, your answer is going to be in amps or amperes, okay? So the unit for current is amperes. And if you measured resistance in a circuit, we know that we're going to come up with ohms for our unit. And the label for each one of those, so that you don't have to write out the whole word, is V, A for amps or amperes, and the omega sign for ohms. I need you to write down this whole table, so pause it, take this whole thing down into your notes. You can skip the E right here, just write the V, write this down, pause the video now. Alright, so here are our three equations. It is super simple. If you can multiply and divide on a calculator, you will have no problem with Ohm's Law. If you want to find voltage, all you have to do is take I times R. So current times resistance. Write that down. If you want to find current, or I, all you have to do is take V divided by R. Voltage divided by resistance. Write that down. If you'd like to find resistance, all you got to do is take V divided by I. Okay, so voltage divided by current. Write that down. Now, even though we have the equations, honestly, you're going to forget them. Some of you will lose your notes. So there's this thing, this Ohm's Law chart, and it's super helpful, especially if you can just take a few seconds, memorize it, and actually put it into practice when we do calculations. The Ohm's Law chart is basically a big circle. It's got a V on top that splits. You got I on the lower left and R on the lower right. All you have to do to figure out what your formula is cover the quantity that is unknown. So let's say that we wanted to solve for voltage. We know current and we know resistance, but we don't know voltage. Take your thumb and put it over V, and hey, it shows you the formula. I next to R is I times R. Okay, so V is I times R. If you want to know, let's say I, current, cover up current, and you get V over R. Okay, V divided by R will give you the solution for current. Okay, and last but not least, if you put your thumb over R and solve for that, okay, it gives you V over I, voltage over current, is how you solve for resistance. Go ahead and draw this thing down. It's super helpful. Alright, we got a new prefix today, okay? We've already learned about this bottom one, the kilo ohms. It means 1,000 ohms, so anything in K ohms is 1,000 ohms. We have a new one today. It's lowercase m and then capital A. So milliamps. Okay, remember A is what you abbreviate amps to. Okay, so milliamp is 0.001 amps. Go ahead and write that down, very important. If you forgot about the kilo ohms already, write that down as well. Here's why we are learning about that, okay? Basically, if your resistance is in k ohms, then your current's going to be in milliamps, okay? So if you have kilo ohms, you're going to have milliamps, or if you have milliamps, you're going to have kilo ohms. Basically, they're paired. So anytime that you have one, let's say we're measuring in a circuit, and we figure out, oh, we're up in the thousands of ohms or in kilo ohms, that means when you are solving for or measuring your amps, it's going to be in milliamps. Okay, so they're always paired together. If there's no prefixes like kilo or milli, then you just use ohms and amps. Okay, so let's say you're measuring resistance and, hey, it's just in regular ohms, like 100 ohms, then guess what? Your amps is just going to be in regular amps. Okay, so that's all the farther we're going today. Please do write that down, though, that prefixes go together. So if your resistance is in k ohms, then your current is going to be in milliamps. Okay, and that if you don't have prefixes, everything's just normal. Okay, so that's all for our Ohm's Law presentation for today. We're going to do a little bit of practice on it as well, so go ahead and look for the assignment on the Google Classroom.